So then, yes sir? I'm sorry? We could convert it to sine and cosines. I don't know that I want to go there yet, but we could, right? I mean, that was an option, right? Sine and cosines. Anything else we could do? It is at this point where I'm like, okay, then if we go back to this, was that the choice then? Like, was that the best choice? Did we choose the right u and the right dv? I'm just trying to think before we go into the sines and cosines. That's all I'm trying to tell you, right? So before we go into sines and cosines, is there maybe, could I attempt something else before I go into sines and cosines, right? Because that's where I'm at currently, right? You guys with me? So the only other thing I could do is to change this, where that's secant, and then that's secant square, right? But I also got to think this through. Do we know the integral of secant? What's the integral of secant? ln of what? Secant x plus tangent x. I don't know that I love where it's taking us, but I'm going to give it a shot before we go into sines and cosines, right? You guys with me? I'm just trying to model to you what I would be doing if I was trying the problem, right? So I tried it, I kind of got stuck, right? Doesn't mean I have to go back to square one. Well, okay, let's see. Let's say we try the different u. So let's say we do u being what? Secant squared x, which means that dv would be secant x dx, right? So then, what would the derivative of u be? Well, this is a chain rule, right? It would be 2 secant of x times the derivative of secant, which is tangent, right? So that would be a secant squared tangent x, right? And then what is this? What is v? Yes? I don't know that I like this one either, but we'll see where it takes us. Alright, so that would be what? That times that, right? So that would be secant square x times the natural log secant x plus tangent x minus that times that. Oof. I do not like that, right? So what's the, I mean, honestly, like at this point, what? Calculator? At this point, it is, I mean, sines and cosines, man, you know? Like, I mean, this, right? Unless, hold on, before, is the derivative of that? Is it? I don't know. Wouldn't that be secant x tangent x plus tangent squared divided by, bless you, secant x plus tangent x? Right? So for this one, no, it's not. No, it's not going to work out. Alright, so sines and cosines? Alright, so here's where we're at. I know like it looks all crazy, but this is the integral we're trying to solve currently, right? Which was, where was it? Secant x tangent square x. Secant square tangent square x. Alright, so where do we want to go from here? Well, integral of is the same thing as 1 over cosine. And this would be the same thing as sine square x over cosine square x dx, right? So technically I have the integral of sine square x over cosine 3x, right? Now, if I go back to the original rules of sine and cosine, they both had to do with odd powers, right? If you have an odd power of sine or cosine, you keep one and you turn the remaining into the opposite of it, right? So in this case, we would have to say, I have a sine square x, right? I'm going to keep one of the cosines, and then the other one becomes a cosine squared, which is the same thing as what? Right? Okay. Where do you want to proceed from here? Let me rewrite it over here. I run out of space. Okay, so that's where we're currently at. Where do we want to go from here? Do the what? Say that one more time. Uh-huh. Mm-hmm. So you're saying like let u be like one of the signs? Is that what you're saying? I mean, yeah, we could rewrite the other one in terms of u. Like we've done it in the past, right? Remember when we had like u equals x plus 1, which means x equals u minus 1? Is that kind of like what you're talking about? Sure, I mean, we could attempt that. Any other suggestions? Integration by parts. All right, I'm thinking this through. Look, here's where we were at, right? Originally. If I would have turned this into cosines, right? Then I could break it into two fractions maybe and see where it takes me from there, right? Maybe, right? Because this would have been 1 minus cosine squared, which would have been 1 over cosine, which would have been secant cubed. Oh no, but we're back to secant cubed. You guys see that? And then we would have a what? A cosine, so another secant over here. What are we missing? I feel like we're missing something. What am I not thinking of? Right. To the other side, like we did on integration by parts. Is that what we're talking about? Okay, so let's see. So let's scratch this, right? And then we say we're gonna keep it as the cosine was gonna. I mean, what was it on top? The sine squared. We're gonna rewrite it as 1 minus cosine square x over cosine 3x, right? Power of 3, which then becomes 1 over cosine, so that'll be a secant cube x minus 1 over cosine, which would be just a secant x dx, right? Okay, so let me kind of back up and rewrite everything we had so we don't get lost. Originally, we started with this, right? We started with secant cube x dx is equal to, and then we did u times v, right? Which got us to, where are we at? Secant x tangent x minus integral of secant x tangent square x dx, right? That's where we started this problem, right? We rewrote that in terms of sines and cosines, right? So we're going to substitute this part with this, right? Do you guys agree? Okay. So we've got secant cube x dx is equal to secant x tangent of x minus secant, oops, I used the integral for my ass, secant cube x dx, right, plus, right, secant x dx. No, because remember, like, when I was simplifying, I ignored that symbol there, so I gotta distribute that symbol. So now what you are saying is to do what? To add this secant to the other side. So that gives you 2 integrals secant cubed x dx is equal to secant x tangent x plus, we know the integral of that, right? What is the integral of secant of x? And what do I have to do then? One half secant x tangent x plus 1/2 ln secant x plus tangent x plus c. There has to be a better way of doing this. I don't know. I mean, we got it, right? Does it make sense? I feel like there has to be an easier way of doing this. Right. But then also, I mean, I don't know if, like, if you're watching this video, I don't know if it was the best way to attack. Like, I know when you watch a video, you kind of want to know the fastest way, but it also kind of hopefully helps you see how, like, you think about the process of a problem, and if you get stuck, how you kind of work around it. Cool. I'll get back to you if I can figure out a faster way. Cool. I don't know. I don't know at this point, but I mean, we did try. We tried our rules. We tried it, and we were able to solve it. Cool. All right. So that's all I got for you today. Quiz next class does not include what we did today. Cool. Quiz next class is just integration by parts and basic integration. Cool. All right. Thanks for watching.